All right, kiddos. So this is going to be your Unit 3, Day 2 lesson video. And in this video, what we're going to be discussing are the trigonometric inverses of sine, cosine, and tangent. So let's jump right in. So here's our EQs. What's an algebraic inverse? What are the algebraic inverses of sine, cosine, and tangent? How do we use those inverses of sine, cosine, and tangent? And what do we use them for? Okay, so let's go ahead and answer EQ1. What are algebraic inverses? So what is the inverse of addition and what is the inverse of subtraction? Well, the answer to that is that these two are both inverses of one another. Addition, adding, is the inverse of subtraction, subtracting. Okay, and it's the same idea here on the second question. What is the inverse of multiplication? What is the inverse of division? And the answer, again, is they are inverses of one another. Multiplication is the inverse of division, and division is the inverse of multiplication. And let's revisit what inverse even means, right? So the inverse of can, obviously, is cannot. Okay, so that same logic is applied here to algebra. Right? So when we're using algebraic inverses, the only time we're going to be using them, which is pretty often, is when we are doing algebra or solving equations for some variable, right? Or doing anything to manipulate that equation. Okay, so first example, 2 plus x equals -1. Essentially what we're doing when we're trying to solve an equation for some variable, in this case the variable is x, we're trying to get that variable by itself. So right here on the left, what's making the equation or what's making the variable not be by itself? We want it to be by itself in a way such that we have x equals and then whatever our answer is. Okay, so what's making it not be by itself? Well, that 2, right? This 2 right here. Okay, that 2 is positive. Okay, that means its inverse would be -2. So what I'm going to do is subtract 2, and what I do to one side of an equation, I have to do to the other, otherwise it's not a balanced equation anymore. Okay, I have to keep the equation balanced, so I took 2 away from one side, that means I have to take 2 away from the other. That leaves me with x equals -3. Okay, and we can check our work. 2 plus -3, well, that does in fact equal -1. So we know we have the right answer. Okay, so example B, we have x minus 4 equals 7. Again, we're going to do the inverse of this -4 to get the x by itself. That's what's making it not be by itself. So we're going to say +4, and what I do to one side, I do to the other. And we're left with x is equal to 11. Right? Then we're here on example C, -3x equals -9. Now, we've got an interesting looking expression. You've seen it a million times, but maybe you still haven't really come to realize what exactly that it means. What exactly that it means is -3 times x. So we have multiplication here, okay, whose inverse is division. So the inverse of times -3 is divided by -3, and what I do to one side, I do to the other. So times -3 divided by -3, these guys are inverses. They undo one another, leaving me with just 1 times x, which is x. And -9 divided by -3, that would be +3, because a negative divided by another negative is a positive. Okay, example D, 2x minus 4 equals -16. So now we've got a few more steps thrown in there besides just the 1. So we're going to have to add 4 to both sides. That's going to give me 2x equals -12. If you're wondering what made the -4 go away, just consider, well, what is -4 plus 4? That negates into 0, right? So that's why it just quote unquote went away, leaving me with just 2x on the left. Anyway, so now I have times 2x, so I'm going to do its inverse divided by 2, and that's going to give me x equals negative 6. Okay, x over negative 5 equals 20. So now we have another interesting expression, x over negative 5. Well, this is literally x divided by negative 5. Right? And division's inverse is multiplication. So the inverse of divided by negative 5 is times negative 5. And what I do to one side, I do to the other. So times negative 5 divided by negative 5, those are inverses. They negate, leaving me with x equals 20 times negative 5. That would be negative 100. Because positive 20 times negative 5 gives me negative 100. Okay, and our last example, we have negative 5x over 3 minus 8 equals 10. I'm going to add 8 to both sides. That's going to give me negative 5x over 3 equals 18. I'm going to multiply by 3 on both sides. And that's going to give me negative 5x is equal to 54. And then I'm going to divide by negative 5 on both sides. And that's going to leave me with x equals negative 54 over 5. Or you could say that this is equal to negative 10.8, I believe, unless I did that wrong, or negative 10 and 4/5. Okay, all of that would be acceptable. Okay, so all of that stuff was simple enough. Little baby review of how to solve equations, right? So now we're going to see, well, how does that apply into geometry and ultimately into trigonometry? So let's look at this first example. So I've got a picture of a triangle, and I don't know either of the angles besides the 90. I know it's a right triangle, but that's all I know. I don't know what theta 1 is, and I don't know what theta 2 is, and that's what the question is asking us to find. Okay, so normally we could set this up as, well, let's look at it in the most obvious way. So obviously 1 square root of 2, 1 to 1 to square root of 2, leg, hypotenuse. This is obviously a 45, 90. Okay, so that means theta 1 and theta 2 are both equal to 45 degrees, right? Now, that's obvious, right? But it's not always going to be so obvious. So we need to look at it in an algebraic sense. And what do I mean by that? Well, we've got a triangle whose hypotenuse, so let's say we're trying to find theta 1. Let's try to find theta 1 first, right? So we can use this adjacent leg and this hypotenuse, right? So adjacent hypotenuse, well, we know that that's cosine, right? And our cosine ratio is going to be, so if I go ahead and just say cosine of theta, that's going to be 1 over our hypotenuse, square root of 2. And that's no bueno because we have an irrational denominator there, so we need to multiply by the square root of 2, top and bottom, to rationalize our bottom number, and we're going to get square root of 2 over the square root of 4, which is equal to square root of 2 over 2. So cosine of theta is equal to the square root of 2 over 2, right? Now, going back a slide, we were using algebraic inverses, right? The arithmetical inverses to solve for a missing variable x, or an unknown variable x. Our unknown variable in this case is theta, right? So we need to undo or use the algebraic inverse of cosine so that we get our variable by itself. Okay, well, what on earth is the algebraic inverse of cosine? The answer is called arccosine. Okay, arccosine. So if I do the inverse of cosine to find the arccosine of theta 1, forgot to put the 1. Anyway, if I go ahead and do that, they're going to cancel out. That leaves me with theta 1 is equal to, well, what I do to one side, I do to the other, arc cosine, square root of 2 over 2. Okay, now this is where we just use our trig table. What we're basically saying is the cosine of what angle gives us a ratio, a cosine ratio, of square root of 2 over 2. And our answer invariably is 45 degrees. Okay? Now, why is it called arccosine? This angle right here, so let me draw a little separate picture here. Let's go ahead and discuss a little bit what an angle is, or not an angle, what an arc is. Okay, so let's say I had a circle. Okay, a circle is a 360-degree arc. Now, it is possible to have arcs of differing degrees, right? So let's say we had this exact same idea. We had a radius of our circle was equal to square root of 2, and our adjacent leg to this central angle here was 1, and we just call that theta 1. This arc on this circle, it wouldn't be 360 degrees anymore. It would only be a 45-degree arc. Okay? So this would be a 45-degree arc. So that's why we call this arc cosine. Okay, so to summarize, our inverse of cosine is arc cosine. Okay, and cosine, sine, tangent, they all have inverses, and all you literally do is just put the word arc in front of it. So the inverse of sine is simply arcsine. And I forgot to write the word arc. Okay, the inverse of tangent is simply arctangent. Okay, so it's simple enough. Just like the inverse of multiplying is division, just like the inverse of subtracting is addition, and so on, the inverse of cosine is arccosine, the inverse of sine is arcsine, the inverse of tangent is arctangent, and that's all there is to it. Now, let's apply it a little bit more algebraically, right? So what we're doing, normally we use our trig table to find what the ratio is, right? What we're doing instead is we're given a ratio and we're trying to find what the angle is associated to that ratio. So what do I mean? Well, let's go ahead and solve this equation here on example 2a. So I've got sine theta over 2 minus 1 equals negative 1/2. Okay, so just like what I was doing before, I'm trying to get theta by itself. Okay, so I'm going to do plus 1 to both sides. That's going to be 1/2 left over here, sine theta over 2. I'm going to multiply by 2 on both sides. That's going to give me sine theta equals 2 over 2, or 1. So now what we've got is simply this, right? So we need to do the inverse of sine. And the inverse of sine, we already know, is arcsine. So that's what we're going to do. That's going to make the arcsine and the sine cancel. And it's an equation, right? So what I do to one side, I also have to do to this side. So I'm going to say theta is equal to the arcsine of 1. Okay, and if you look on your trig table, you have to think the sine of what angle gives you 1? And that very simply is theta must be 90 degrees. Okay, let's do another one. Two cosine theta is equal to the square root of 3. I'm going to divide by 2 on both sides. Cosine theta equals square root of 3 over 2. Okay, and I'm going to take the arc cosine of both sides. Now, here's me writing arc cosine in a different way. Instead of saying arc cosine and actually like spelling it out, you could also just put a little -1, like an exponent right here. And what that means is, and you'll see this in Algebra 2, that means inverse, right? And the inverse of cosine is arc cosine. Okay? Anyway, so theta is equal to our arc cosine of the square root of 3 over 2, and that means that theta is equal to 30 degrees. All right, let's do another one. Let's do example C now. And I mean, this is pretty, it's not as bad as it looks. So we have tangent theta all squared. And another way to say that, let me go ahead and recopy the whole thing. We could also say, instead of tangent theta and then in parentheses squared, we could say tangent squared theta, like that. So I'm going to go ahead and write it that way because you need to get used to seeing it that way. Anyway, we're going to go ahead and subtract 2 on both sides. So I've got tangent squared theta is equal to 3. Now, we need to do 2 things. We need to get rid of the tangent, and we need to get rid of the exponent. It's being squared. So we need to do the inverse of squaring, which is taking the square root. Where I do to one side, I do the other. So I've got tangent theta equals square root of 3, and theta, therefore, equals the arctangent of the square root of 3, which is 60 degrees. Let's do a couple more. I think after seeing this just a few times, you'll get the hang of it. So 6 sine theta is equal to 3 square root of 2. Divide by 6 on both sides. And we can go ahead and reduce the 3 and the 6 by a factor of 3. So we're left with square root of 2 over 2. Take the arcsine of both sides. Theta is equal to the arcsine of the square root of 2 over 2. And that means theta is simply 45 degrees. All right, let's do another one. Let's see. So I've got 10 cosine theta equals 5. Divide by 10 on both sides. That would reduce down to 1/2. Take the arc cosine of both sides. Right? And that just means that theta must be 60 degrees. Okay, one more example. Tangent theta equals 5. Divide by 5 on both sides. Take the arctangent of both sides. And we're going to get 45 degrees. Okay, so pretty straightforward stuff. So now let's actually apply it to some real triangles. Okay, so here on triangle A, let's go ahead and try and find theta 1 first. So I'm going to go ahead and say I'm going to use sine. So I'm going to use the opposite and the hypotenuse. So I'm going to say sine of theta 1 is equal to 3 over 6. That reduces down to 1/2. Take the arcsine of both sides. That leaves me with theta 1 equals the arcsine of 1/2. And theta 1 must be 30 degrees. Okay, easy enough. So we found theta 1. Now let's find theta 2. And for theta 2, I'm going to go ahead and do, let's do tangent. So tangent of theta 2 is equal to opposite. So that would be 3 square root of 3 over adjacent over 3. Okay, so I'm just going to reduce. So 3, 3, that's going to leave me with just the square root of 3. And take the arctangent of both sides. Theta 2, therefore, is equal to the arctangent of the square root of 3, which, of course, is 60 degrees. Okay, so this is all pretty straightforward. I'll do one more example just because I don't want this video to run too long. I'm already past 20 minutes. I'll do, let me see, which one do I think you need to see? I mean, they all end up working out the same way. Okay, let's do example D because this looks like the ugliest one on here. So I'll go ahead and do this one. So I want to start out by finding theta 1 just because, I'm numerical like that. And I'm going to use sine this time because I didn't use it in the last problem. So sine of theta 1 is equal to opposites over hypotenuse. So 6 square root of 2 over 4 square root of 6, right? Go ahead and reduce. So 6 and 4 will reduce down to 3 square root of 2 over brain fart. Square root of 6. We cannot have an irrational denominator, so I've got 3. Oops. I'm going to multiply by the square root of 6 on top and bottom. And that's going to give me 3 square root of 12 over 6. 3 over 6 reduces down to 1/2. So I've got square root of 12 over 2. I can go ahead and factor the square root of 12, right? The square root of 12 can be broken down into 4 and 3. And the 4 can be broken down into 2 and 2. And there's my square, left with 3. So 2 squared. So the square root of 2 squared times the square root of 3, that leaves me with 2 square root of 3. So that means that this guy is 2 square root of 3 over 2. And, well, maybe there's a mistake on here. Okay, I found my goof. There should be a 2 right there. When I reduced the 6 and the 4, I just forgot to write the 2. So the 6 became a 3, the 4 became a 2. Okay, so that changes this. So there's still a times 2 there. So this should be a 4. Here, I'll tell you what. Let me just start over on this. How about that? Because that may completely throw you off. And that's what I get for trying to go so fast. Okay, so I was using sine. Sine of theta 1 is equal to opposites over hypotenuse. Okay, so we're going to reduce to 3 square root of 2 over 2 square root of 6. Because of the 6 and the 4, they have the common, we call it, common factor of 2. Okay, so now I'm going to multiply by square root of 6 over square root of 6 so that I can rationalize this guy here. That's no bueno. So that's going to leave me with 3 square root of 12 over square root of 6 times square root of 6 gives me 6, and then 6 times 2 gives me 12. Going from here to here, of course. Okay, I can go ahead and reduce the 3 and the 12. So that's going to leave me with square root of 12 over 4. Okay, square root of 12, we already saw, reduces down. I went ahead and left that up here, to 2 square root of 3. So that means I've got 2 square root of 3 over 4. 2 and the 4 reduce down. So that's going to leave me with square root of 3 over 2 is equal to the sine of theta 1. And we want to take the arcsine of both sides of that. Okay, and we're left with theta 1 equals the arcsine of the square root of 3 over 2, which of course is equal to 60 degrees. So that means this angle here, theta 1, is 60 degrees. And if I'm working smart, not hard, if this guy is 60, that means this guy over here has to be 30. Okay, so pretty straightforward. Just make sure you're not going 100 miles an hour like I am, and then you make a stupid mistake. Anyway, so that pretty much brings this into conclusion. So we answered all 4 of these EQs. And what you need to be working on right now, of course, is your applied practice 2 that's assigned to you already on Google Classroom. Come through tutoring, ask a crap ton of questions. You guys know I'm here for you. All right, that's it. Goodbye.